Hello everyone, this is Dr. Young, and in this video we are going to talk about how to find those reductions and oxidations in the redox reaction equations that you have, right? So hopefully you've already watched the video on oxidation states, because that's a crucial skill that you're going to need in order to determine what was oxidized and what was reduced. So remember, right, we did these redox reactions, we talked about things can rust, we talked about how important they are for metabolism, and the next thing that we're going to talk about is how I'll do it right now, but you will be able to just say, oh, hey, look, iron was oxidized, and it looks like oxygen was reduced. And so we're going to talk about how you figure that out. What skills do we need in order to be able to determine that? So how to determine what was oxidized and what was reduced? First step is to assign all those oxidation states, right? So this is exactly what I was talking about in that previous video. So if I look at this equation down here, iron plus oxygen makes the iron 3 oxide. Iron, the first part here, right, this iron, that's a pure element. O2 is a pure element. Iron oxide is an ionic compound. So I'm going to follow those rules that we talked about before, where all elements are 0. So I know iron was 0, oxygen was 0. And then since we have iron 3 oxide, if I go through those rules, I know that all the oxygens are -2s, and then these irons must be +3s in order for everything to balance out, right? So I have 6 negatives, 6 positives. So once I've assigned all of my oxidation states, then I look at what happened to those different elements. So for example, if an element has lost electrons, or in other words, we increased the oxidation state, that means it's oxidized. If any element gains electrons, or in other words, it decreases its oxidation states, that means it was reduced. So if I look at, let's do this one. If I look at the iron, for example, iron goes from 0 to +3. It goes from 0 to +3. How would an atom go from 0 to +3? Remember that when things become positive, that means they lost electrons. So if iron goes from 0 to +3 charge, that means that it lost, I'll even put it here, it lost 3 electrons, right, to go from 0 to +3. And if it lost electrons, we said that means that it was oxidized. This was an oxidation reaction. Or in other words, iron was oxidized, right? That's what this sentence is saying. Any element that lost electrons was oxidized. Iron lost electrons. Now, conversely, we could look at the oxygen here. Oxygen goes from 0 to -2, or in other words, it gained, each oxygen atom gained 2 electrons, right? That's how it got the -2 charge, just like regular ions. It gained 2 electrons to become -2, or in other words, it was reduced. It got reduced. And so we can look at any redox reaction and do this and see that the oxidation number changed. That's how we know it's a redox reaction. And we can say what species, what atom in it was oxidized and what was reduced. Where was the oxidation? Where was that reduction? Now, I just want to put a couple of mnemonics up here for you. One is that if you look at oxidation states, and I'll just do up to 4 here, 3 plus 2 plus 1, 0, -1, -2, -3, -4. What you can say, one thing you can say is that as you move up this, right, as you go from -4 all the way up to +4, you're getting more oxidized. Right? So going from -4 to -2 is an oxidation because you've lost 2 electrons. Going from -1 to +1 is also an oxidation because you've lost electrons. And we can say the opposite is true also. We can say that as you move down this, you get more reduced. Right? You've reduced the oxidation number. The oxidation number is lower. It's reduced, right? If you go from 3 to 1, that's a reduction in number, right? Imagine that you had $300 in your bank account, now you have $100 in your bank account. You've reduced the number of dollars in your bank account, right? Reductions are moving as you go down to more and more negative numbers. Another way that people remember oxidation versus reduction is there's a mnemonic called oil rig. So oil rig. An oil rig is supposed to stand for oxidation is loss of electrons. So O-I-L, oil, right? Oil oxidation is loss. And Rig, where reduction is gain of electrons. So Rig, R-I-G. So oil rig is sometimes also a mnemonic that people use to remember, help them remember what's an oxidation, what's a reduction. Oxidations are always when you lose electrons. Reductions are always when you gain electrons. Oxidation is when the oxidation state goes up. Reductions are when the oxidation state is reduced, when it goes down. So let's look at some more examples. Here's two more equations where I just want to know what was oxidized and what was reduced. Just like I did on that previous page. So the first thing again is to assign the oxidation states. I'll go ahead and do that, right? Pure element, pure element. I have an ionic compound, so I know that sodium's +1, chloride's -1. And then if I look at this, I'm trying to look for which one's oxidized. The thing that lost electrons, in this case sodium, is the thing that was oxidized. This was the oxidation. If I look now at the Cl, it goes from 0 to -1. It gained an electron. It gained 1 electron, and therefore that's the reduction. If I go to the second one, same thing. This one's a little more complicated, but not too much. First, I have a compound, so I'm going to follow those same sorts of rules. It's an ionic compound, so I can just say that sulfur is -2 and aluminum is +3. And I've got silver as an element, so that's 0. Then I have silver 1 sulfide, so that would be a -2 and a +1. And then aluminum is an element, so that's 0. So you can see how being able to determine these oxidation numbers quickly is really going to help you out when you're trying to answer these questions. So what lost electrons? What lost electrons? It looks to me like silver lost electrons because it went from 0 to +1. Oxidation. And now if I take a look at, well, what was reduced, aluminum was at +3 and now it's down at 0. And so that means it gained electrons and it was reduced. Now, one thing that happened, if you're looking at all these, you might be thinking to yourself, hey, well, what's going on with sulfur? Sulfur was -2, and I'm kind of going to swing around here, and it's still -2. Nothing happened to sulfur. It was neither reduced nor oxidized. So just because if you're doing a redox reaction, it's not like every element has to change its oxidation state. Only 2 elements. Well, I shouldn't say that. Probably just 2 elements are going to change the oxidation states, maybe more, but not everything has to. Maybe everything will, but maybe it won't. At least 2 things will change the oxidation states in a redox reaction. So in this case, sulfur didn't change at all. Sulfur didn't change at all. Silver was oxidized. Aluminum was reduced. So here's 3 questions that are types of things you might see on an exam or homework or something like that, or how we might apply these. So I will let you read these, pause here, and see what you can do with them, right? See what you can do with them. The first question is just giving you a reaction, asking you what's oxidized, what's reduced. Second one is asking you to identify the type of reaction, right? Is it acid-base? Is it a combustion reaction? Is it a redox reaction? Is it a precipitation reaction? And then the third one is asking you to figure out what was oxidized and what was reduced and explain your reasoning. So go ahead and hit pause, see what you can do with these. Okay, so let's take a look at this. So in the first question, in the reaction shown, which reactant is oxidized? So again, I'm looking for an increase in that oxidation state, or in other words, a loss of electrons. So I see manganese is just written out as an ion, so I know that's +2. Bromine's an element, so that's 0. This manganese is +3, and then this bromide is already just written out as a -1, so all those oxidation states are pretty easy to do. So I'm looking for which one is oxidized, or in other words, lost an electron. And I see that manganese goes from +2 to +3, which means it lost an electron, or in other words, that's what was oxidized. That's what was oxidized. Bromine apparently was reduced. This question is just asking about what was oxidized, though. And it looks like the manganese 2 plus was oxidized to form manganese 3 plus. So I circle manganese 2 plus because that's what was oxidized. And it also says reactant, so I know it's on the left-hand side of the equation. Now for number 2, what type of reaction does each of the following equations represent? How can you tell? Remember that our main options here are going to be combustion, which is easy to spot, right? Because you're always going to have O2 on the left, you're going to have CO2 and H2O on the right. So that's pretty easy to spot. You're going to have your acid-base reactions. That's where you're going to, right, you're going to transfer a proton. I'll say transfer a proton. Proton transfer. You have precipitation reactions. Where basically, right, you need to form, well, let me do this. Basically, in precipitation reactions, you're going to have an aqueous thing plus an aqueous thing, and you're going to form a solid thing. And then the last one, we have the redox reactions, right? What we're looking for here is a change in oxidation state. I need a change in that oxidation number, that oxidation state. This is the order in which I recommend you think about them, just because it's kind of like easy to hardest, or least amount of work to most amount of work. Because combustions, right, should be really straightforward to spot. So for example, I know this first one is not a combustion because I don't see any O2, I don't see any CO2 in water. So I know it's not combustion. I also know it's not acid-base because I don't see any H pluses at all. So that's out. And I cannot say it's precipitation because I don't even see the states. In this example, I didn't draw any states, so there's no way you could know if it's precipitation or not. Which leaves just redox. I mean, there's other types, but just redox. So that means I need to check to see if these oxidation states changed. So aluminum was 0, iron was -2, sorry, iron was +3, oxygen was -2, this iron is 0, aluminum is +3, oxygen's -2. And sure enough, right, I see things like the aluminum goes from 0 to +3, and I see that the iron goes from 3 down to 0. So that was definitely redox. And then I would say, I mean, I don't have time, I don't have the space, sorry, to write out this answer. But what I would say, if I was going to say, how can I tell? I'd say because the oxidation states change during the reaction. Now, if I look at the one below it, I have this equation. Again, I'm going to go down my list. Is it combustion? Does it have O2 as a reactant and CO2 and water as products? Yep. And then I'm done. I'm not even going to look at the other ones. I'm not going to do anything else. So combustion. And my rationale for combustion would be because oxygen is a reactant, carbon dioxide and water are products. That's really all I got to say. Now for the third question, in the below equation, which element is being reduced, which is being oxidized? Explain your answer. So again, if I want to know what's oxidized and reduced, I got to put in these numbers. So I got a 0. I see here that there's sulfate and sulfate, so I'm going to ignore that because the sulfates are the same, or in other words, nothing changed. So I'm going to ignore the sulfate. But I do know that overall the sulfate's a -2, so this copper must be +2. That makes this zinc a +2, and that makes this copper 0. So what was oxidized? It looks like zinc was oxidized. So I'll say zinc lost 2 electrons. Which means it was oxidized. And then I need to find something that was reduced, and luckily it looks like my copper 2 plus goes down to copper 0, so I can say copper gained 2 electrons, which means it was reduced. All right, and those would be perfectly acceptable answers. So what we're going to do next in the next video is talk about half reactions. So sometimes we need to talk about the half reactions, or we only really care about what's happening with the zinc or what's happening with the copper. So you may be asked to write half reactions. So that will be what's in the next video. So practice this stuff, study up, and good luck.